This example is going to show you one way that we can receive the information to make a vector in a certain direction with any magnitude. This is going to be using the formula that we talked about in the previous video. This is our formula, and we're going to fill in those pieces somehow using the information given. Now the information given here is that we are going to have a magnitude of 10 in the direction of 1, 3. So I want to highlight the direction of this first. If it gives you the direction in terms of a vector, what we're going to do with it first is actually draw out that vector on the plane. So as you see, I've drawn this vector that's 1, 3, and I've got the vector drawn to connect the initial point to the terminal point. Now we want to know what this vector is all about, and so one thing that we oftentimes do is we find out what this magnitude is. It's basically the hypotenuse of the right triangle. So you're going to see, the same types of things with Pythagorean theorem and with magnitude and with hypotenuse in a lot of cases. So in this case, we want to know what that is. We just do the square root of 1 squared plus 3 squared, which is going to be square root of 10. We'll leave it as a square root, but that is going to be what we have for the magnitude right now of that one. Now we don't want square root of 10 to be the magnitude. We want the magnitude to be 10. So we're going to apply this formula and fill in the missing pieces here. So bringing this stuff down, one thing that's really easy to determine here for our vector is this spot. This spot means what's the magnitude of the vector, and so the magnitude they give us is 10, so that's automatic. We get to just put that in right there. Now we need to find the cosine and the sine because we don't have an actual angle to look at here. We don't know what this is. We have to rely on the triangle setup that we have to actually tell us the cosine value and the sine value, and that will give us our new vector. So the cosine of alpha, cosine is adjacent over hypotenuse, so we can fill that in for right now as 1 over square root of 10. We will simplify in a little bit. And then we can do the sine as our y value. That's going to be 3 over the square root of 10. So this is the raw form of our vector. We do want to simplify. We do want to distribute that 10 in eventually, but let's leave the 10 outside for now. We simplify these two by multiplying by square root of 10 top and bottom. So that's going to be square root of 10 over 10. And then over here it's going to be 3 square root of 10 over 10. All right, we're almost there. Now we need to get an overall vector. We want that 10 out of there. We want to distribute that into the vector itself. We do that, the 10's basically cancel out. So our final vector in this case is going to be square root of 10 and 3 square root of 10. What we have done is we've created a vector that is in the direction of 1, 3, so it's along this line, but this is going to have a magnitude of 10. So if you run this through the square root formula like we're used to seeing for magnitude, you'll find that the magnitude is 10, and that's what this formula does.